The Pompeii worm, Alvanella pompeiana, chooses the boundary between life and death at East Pacific Rise hydrothermal mists 2,500 meters down to call home. The greatest biological anomaly of this 10-centimeter creature lies in its unprecedented ability to endure an inverted temperature gradient across a single body. Its tail sits deep inside its tube attached to the chimney wall, where the venting fluid hits a steady 50 to 55 degrees Celsius, with short thermal spikes reaching up to 80 degrees Celsius. Conversely, its head, bearing respiratory tentacles, pokes out into the freezing deep-sea water at just 22 degrees Celsius. This extreme difference creates a staggering thermal gradient of nearly 60 degrees Celsius along a body length of less than a span. To keep its skin from liquefying, the Pompeii worm possesses two cutting-edge weapons. First is a 1-centimeter thick layer of symbiotic filamentous bacteria covering its back, acting as an insulating blanket and absorbing toxic heavy metals from the vent. Second is a specialized genome encoding proteins with high levels of small charged amino acids like alanine and tyr. This creates ultra-stable structural chain links that resist denaturing or unfolding at temperatures that would instantly destroy ordinary animal tissue. It doesn't flee the heat. It turns its body into a mechanical heat sink, actively regulating water flow to survive. The Hawaiian lava cricket, Caconemobius fori, measures about 9 millimeters in length and features a shiny black coloration identical to volcanic glass droplets. When catastrophic eruptions incinerate all life, they turn the scorching rock fields into their home turf, appearing just 3 months after the lava flows solidify. This species is entirely wingless, meaning they cannot fly to migrate and are unable to chirp to call for mates like ordinary crickets. Their most bizarre and brutal biological trait lies in their mating behavior for survival. In other cricket species, the female bites the male's leg spur to drink protein-rich hemolymph as a nuptial gift, causing the male to lose up to 8% of his body weight. However, in the barren lava environment where daytime temperatures exceed 50 degrees Celsius, losing water and bodily fluids is a death sentence. Consequently, male lava crickets have evolved to completely eliminate this leg spur to retain every drop of life. In return, the female faces immense reproductive pressure, laying a much smaller number of eggs, but each egg is significantly larger to ensure the nymphs have enough nutrients to survive. They only exist on raw lava flows under 50 years old. As soon as the first seed sprouts and vegetation approaches within a 15-meter radius, the lava crickets instantly vanish. They choose to live in isolation on barren rocks, feeding on seafoam and organic debris blown in by the wind. The vent shrimp. At depth of 11,000 feet beneath the Atlantic, where sunlight is absolute zero, the shrimp Rimicaris exoculata has completely restructured its biological navigation. Its most bizarre adaptation is discarding traditional eyes and moving an infrared camera onto its back. Nature stripped away obsolete visual organs and replaced them with a rhodopsin pigment patch right beneath the transparent cuticle on its shoulder blades. This organ works like an ultra-sensitive smoke detector, sensing thermal radiation from hydrothermal vents. Fluid shoots from Earth's furnace at 662 Fahrenheit, hot enough to dissolve the shrimp in seconds. The animal must maintain a precise life or death distance, close enough to feed the bacterial mats inside its gill chambers, but far enough to avoid being cooked. It turns its body into a mobile farm, contracting with bacteria for nutrition. While a high-end thermal camera reads heat at 50 feet, this blind shrimp senses radiation by thermal feel alone in pitch darkness. It is a living fire alarm glued to its own back, constantly calculating the line between life and soup. At a depth of 13,000 feet along the East Pacific Rise, there is a creature carrying one of the strangest evolutionary paradoxes on the planet. This is the vent crab, Bythagria thermodron. Born in shallow sunlit waters, their larvae possess fully functional compound eyes to see the world. But as adults, they make a one-way journey down into the eternal abyss, where pressure hits 400 atmospheres and sunlight is zero. Down here, their eyes degenerate completely, turning into useless, blurry streaks. However, the most bizarre anomaly is that the retina of this crab still retains its chemical structure calibrated for surface sunlight. Instead of discarding the old optic wiring like cavefish do, the vent crab keeps the entire circuitry to perform a single task: catching the infrared radiation emitting from black smokers heated up to 350 degrees Celsius. They are blind to everything else, but they can see the burning death right in front of them to stay away. The life of this baguette-sized crab is a continuous cycle of scrambling over toxic sulfur-laden rock walls. They move constantly within a narrow temperature interface of 2 degrees Celsius true to hunt limpets and graze on chemosynthetic bacteria. Creep an inch closer, and their shells cook in seconds. Step back, and their bodies snail. 2 miles down on Indian Ocean hydrothermal vents, there is a biological anomaly that wears a suit of rusted plate armor. It doesn't forge this metal, the volcano does the metallurgy. This is the only animal on Earth known to incorporate iron sulfide into its skeleton, turning environmental toxic waste into structural defense. The snail grows soft scales on its foot, and the vent water precipitates iron straight onto them. It's like wearing a chainmail shirt where the rust is what holds you together. This armor isn't a free gift from the deep. A typical animal heart makes up 0.5% of its body volume. A hummingbird hits 2%. This snail's heart takes up a massive 4% of its body. It needs that oversized pump just to circulate oxygen through a body weighed down by literal rock. The most bizarre biological twist? It has a massive ironclad home but completely outsourced its metabolism. As an adult, it has no functional digestive system. Inside its trophism organ, billions of chemosynthetic bacteria turn toxic sulfur into sugars. The snail eats exactly nothing. The bacteria generate the fuel, and the snail provides the raw chemicals. The deep-sea mussel Bathymodiolus thermophilus. Living in ditch beds around hydrothermal vents at depths of 2,500 meters along the East Pacific Rise, this species boasts an impressive shell length of up to 20 centimeters, 8 inches. The most bizarre biological trait of this mussel is its ability to simultaneously operate 2 opposing energy metabolic pathways within a single body. Unlike the giant tube worm, which has completely lost its mouth and gut, this vent mussel retains its traditional digestive system fully intact. Inside its giant gill filaments, it hosts billions of chemosynthetic bacteria. These bacteria absorb toxic hydrogen sulfide gas from the vents to produce sugars that nourish the mussel. When the mineral-rich fluid erupts heavily, the mussel relies on internal energy from its bacterial farm. When the vent fluid weakens or shuts down completely, it immediately filters seawater to consume organic detritus the traditional way. A typical regular mussel filters 1 liter of water per hour, and an oyster cleans 190 liters a day. But this vent mussel can run automated water filtration while managing its own bacterial farm to toggle flexibly between the two. On a single volcanic slope in the Galapagos, there is a lizard whose striking coloration is not a fashion statement, but a total absence of skin pigment that lets you see its blood pumping underneath. The pink iguana, Caconemobius marthae, lives exclusively on the northwest slopes of Wolf Volcano, occupying an incredibly restricted home range of just 25 square kilometers. It is one of the oldest divergence events in the archipelago, having split from other land iguanas 5.7 million years ago, yet scientists only officially recognized it in 2009. The most bizarre biological trait of this creature is its genetic lack of photoprotective melanin across large patches of its adult body. This complete lack of pigment means it absorbs solar radiation differently, forcing the pink iguana to actively avoid high ultraviolet B UVB exposure. Unlike its yellow neighbors that bask openly in intense equatorial sunlight, the pink iguana is morphologically driven to hide in dense, shaded microhabitats to prevent radiation damage to its unshielded dermis. It manages to survive on an active volcano that erupted in 2015 and 2022, maintaining a critically endangered wild population estimated at only 189 to 300 adults. An adult human has around 4% genetic difference from a chimpanzee. This pink lizard maintains a 4% genetic difference from the yellow iguana it lives right next to, a gap wide enough to alter its entire lifestyle. Kiwa hirsuta, living at depths of 7,200 feet in the South Pacific, is a crustacean that chose to operate an agricultural farm right on its own claws. This 6-inch, blind, bleached creature possesses the most bizarre biological trait: a dense coating of hair packed with a massive density of filamentous bacteria. It does not hunt, nor does it scavenge. Its digestive system has been entirely reshaped to depend solely on harvesting this microbial vegetable garden. While other species struggle to find food in the pitch black, this crab simply waves its claws into the sulfide-rich hydrothermal vent fluid to nourish the bacterial cells, then uses specialized mouth parts to comb the hair clean for a meal. a bizarre self-sustaining ecosystem. For comparison, a cow needs acres of pasture to ruminate. A polar bear requires a hunting territory spanning hundreds of square miles. This crab packs its entire lifetime food supply into a space of just a few inches on its set of hairs. Research data shows its habitat is strictly restricted. If it moves more than a few meters away from the warm, chemical-laden vent water, the bacteria die and the crab starves. If it gets too close to zones where temperatures exceed 350 degrees Celsius, its shell gets cooked instantly. Its survival boundary is a narrow strip less than 50 centimeters wide. The Galapagos marine iguana, Amblyrhynchus cristatus, is the only reptile on Earth that forages for food in the ocean. Their greatest challenge is not sharks, but El Niño. When warm currents arrive, marine algae beds, their sole food source, are destroyed en masse, driving the population into starvation with mortality rates up to 90%. To survive this catastrophe, this creature triggers a bizarre mechanism unparalleled in vertebrates: bone shrinkage. They do not just lose fat or muscle. They literally reabsorb cartilage and bone structure back into their bodies. Scientific data records that their body length decreases by up to 20% within just 2 years of famine. Accompanying this downsize is a radical austerity strategy. Body mass drops by 17%, torso circumference shrinks by 12%, and the resting metabolic rate plummets to a record low of 20%. A smaller body means lower energy requirements, allowing them to sustain life on the meager remaining algae. When La Niña returns and food becomes abundant, their bones automatically regenerate and regrow to their original size. They are biological coil springs, contracting and expanding their bodies according to the planet's harsh cycles.